Okay, we're ready to get started again. Our next speakers are Satheesh Subramanian. He's the VP of Engineering of Augmented Reality at Blippar, and Ryan Schmaltz, who's the EVP at Blippar. Please give it up for Blippar.
Hi, everyone. Just to get started by way of introduction, for those of you that don't know about Blippar or just learning about it here at Augmented World Expo, we want to give you just a little bit of background on who we are and really where we've come from. So back in 2000, we made blipping really a verb, and it was really at that time we were trying to see if this whole augmented reality thing had legs. And that meant us starting with some of the largest brands and figuring out how to create augmented reality experiences that enabled them to create, reach out to their customers and clients, engage with their users, and find new ways of unlocking brand content, either on shelf space or in media, and then also looking at media as a form of print media and how to connect that with digital content. And what we quickly learned throughout that is that we really had three sort of key observations that we learned as part of those early days. And the first thing is that once people have an amazing AR experience, they want to have more. And the first thing they do is immediately take that blippable content and they try to blip their hand or their foot or their friend's face who's sitting next to them. And so what we learned is we have to really strive to make the entire world more augmented, more blippable. And that really led to our second observation, that the only way to really effectively create a world of augmented reality, we had to combine it with computer vision and machine learning. And what we learned is that words as a whole are just not enough. You type in red dress in a search engine, or you try to look up a plant. You can't get at the specificity of an object when you're doing that, and computer vision and machine learning allows us to get there. We have some really exciting announcements coming out in the next few weeks about that, but today what we really want to focus on is the third technology, or the third observation, which is up to now, Blippar's core technology has been behind closed doors, and so we've been working on it in-house, developing experiences for these brands, like I mentioned before. And today we're announcing the release of our API beta, which is rolling out, and you can sign up live on our website today. Satheesh is up here with me. He's going to take you through a lot of the nuances of the API. But what's really cool about it, one, is it's very, very powerful, and two, it allows you to create content on Blippar's platform with our 65 million user base, and create those AR experiences for potentially your customers, for your own enjoyment, for education, and with that, I want to hand it off to Satheesh to talk a little bit more about it.
Hi, everybody. Thanks, Ryan, for the nice introduction about Blippar's history. I would like to start off my my part of the conversation with a quick video. This is showcasing what Blippar did for residents in Marriott, where they had a specific need, where they wanted to connect and provide a networking opportunity for their guests. And this is a blip that was created for Marriott.
Using Blippar's technology to get people to interact with each other by playing trivia games. They can take pictures to create a postcard using Boston landmarks, and find beer pairings.
Have a great time tonight. Remember, use the Blippar app. It's one of the neatest things. You'll be able to play the trivia game. We've got some fantastic prizes.
So the idea is people are gonna, come to the happy hour mix event, blip a coaster or blip the coasters that are around the area, and it's gonna come to life. And what we'll see is options to play trivia, which is what we really want people to do to, have fun, good icebreaker to meet with people. So it should be a really fun experience for everyone at the happy hour.
the residents in. You have a $200 gift card. Very good.
So as you may have seen, this is not about, augmented reality is not essentially about creating like AAA games. Augmented reality is about creating experiences that engage with your audience at a different level than they are used to. So what makes this experience? Today, augmented reality is predominantly driven by marker-based approaches, and Blippar is a marker-based system at this time. So you have a marker, and then when somebody blips that marker, what you end up doing is recognizing what that marker is, and it doesn't need any code or anything like that to go on the marker. We are an image-based recognition system. So as the image is recognized, then you can actually fetch the media assets that you put together to make your blip what it is. And what kind of media assets can you have today? 3D models, images, audio, and video. And then you add some scripted behavior to it. And when I say scripted behavior, like in that example, you had this, the trivia game kind of coming from underneath that card, right? Now that is scripted behavior. It's not your static model, it's scripted behavior. And how do you get that scripted behavior in? Through JavaScript. So with this, basic structure in place, you can start to create some really interactive blips and content that makes sense for your particular use case. In terms of what kind of formats we support at this moment, we have markers being predominantly JPEG. They should be RGB without any alpha. Through our experiences building these blips for some of our big clients and some of our popular blips, we have noticed that marker sizes tend to be, the ideal size would be like 300 by 300 pixels to 800 by 800 pixels. And that way you can cater to all of the different mobile hardware needs. And it also helps with recognition, the speed of recognition, as well as the delivery of the blip to the Blippar app. 3D models, when Blippar started off, we created our own custom implementation of the popular Quake MD2 file format. It has just been modified primarily for improving transport over the network, as well as for loading up within the app at a much faster rate. We support animations that is baked into the model on a per frame, on a keyframe basis, with interpolation between the keyframes. We also provide plugins for popular 3D content creation tools, where you can export these models out for, let's say if you're using Blender or 3ds Max, you have plugins that would export out the MD2 models from from those tools. Images, we primarily support JPEG, PNG 24, PNG 8, and PNG 32. For JPEG images, you can supply pair the image of the original image and the alpha mask, and we'll use that to provide transparency on your JPEG images. For audio, we support like OGG, MP3, and .wave. Wave is primarily used in the Windows platform for Windows phones. Video, we have support for MP4, and you can also do chroma keying on the videos, so that if you have chroma channels on your recorded videos, you can supply the chroma key value, and we'll subtract that out. So how do you create a blip? What does it take actually to create a blip? So here was a blip that I created like yesterday in preparation for this presentation. It took me about 5 minutes to create the blip, publish it live, and as you can see, it's about like 6 lines of code to create your first blip, right? So what are you doing here? You're kind of first requiring the Blippar library, the JavaScript library, and you're creating a scene. A scene is basically where what your entire experience is built upon. And when the scene is getting created, we just say that I want to create a sprite, which in this case is the Blipper logo on top of the marker, which in this case is the AWE splash screen. And once you have this main.js is what is your entry point into the Blip, and it gets loaded and it gets run by the engine. And you can package it using, if you guys are familiar with Node.js or Node.js way of packaging JavaScript library, JavaScript content, it follows a very similar structure and style. And as you may have also seen with the require module being used there. So we want to encourage people who have traditionally come from the web dev background to kind of start to create their augmented reality content in ways that they are used to creating web content. So what does our tech stack really look like? What you see in that big box with all of those smaller boxes is basically what happens on the app. And what rides on top of that is your Blip that you create as a developer. And what is riding on our cloud backend layer are two main things, which is the visual search that actually drives your image recognition. So it's a cloud-based recognition engine. And it is beyond just cloud-based recognition. It also does more. It also provides you more information through using our deep learning system. And like Ryan said, you'll hear more about it in the upcoming weeks. The CMS system is where developers would traditionally build their blips, publish it, manage it. So the CMS system has versioning, and it has the ability for you to put your blip on a test, on what we call as a test code, which is how you would test a blip, and so on. I'll go into more details later. Fundamentally, on the app side, what the Blippar app is built upon is the general abstraction layer for graphics, which is currently we support iOS, Android, and Windows phones. So we do have rendering abstraction layers for OpenGL and DirectX. And we also have native input abstraction layers for camera, touch, gyro, network, audio, whatnot. And sitting on top of that layer is our proprietary tracking engine, as well as our client-side recognition systems. And together, you have the client-side recognition system capturing the image and understanding your marker, and the tracking engine providing the target on which your blip is going to ride upon. You can have a marker that is used for detection that is different from the marker that is used for tracking. So a good example in some cases is when you have a book published, publisher wanting to blip something, you would have the detection marker be something that is more contains all the text and other stuff, and then the tracking marker, because the book is published on a very shiny a piece of paper, it might not track well if you don't provide some more additional information. So those are areas where you can provide a detect marker, which is different from a tracking image. The Blippar C++ layer rides on top of that, and while we don't currently expose the C++ layer because it's much harder to write to that layer than it is to write it in JavaScript. So the Blippar C++ interface provides a lot of the handles all of the high performance tracking and rendering, while the layer that is exposed to developers this time is the Blippar JavaScript API, which writes very tightly and talks to the Blippar C++ layer. So which means that you are not looking at the JavaScript API as running within a web view, which might be much slower than if it is directly talking to the C++ layer. And on top of that, in the app, we have application support layers, which provide for things like caching your blips, history of recently blipped items, and trending blips in your neighborhood and things like that. So what is a blip, right? In terms of its organization. So you have two things. One is you have a static representation of your blip, which is a JSON format, which we will again publish, and anybody can theoretically write to that static layer from whichever tools you're using. if let's say you are building most of your scenes in 3D Studio Max or Maya or any of the other 3D packages outside, you can write your own exporters, if you want, to the Blippar JSON format. And once you write it to the Blippar JSON format, with just one line of code, you can load that file in, and you have your static scene available to view in the Blip. You can add more dynamics to the scene. You can add interaction, like now on click, do something, animate the arm, things like that, using JavaScript. And the entry point, like I showed you earlier, is main.js. In a Blip, there are two primary spaces that in the Blippar engine provides, two primary spaces. One is the marker space, anything that you want to ride on top of your marker, right? The other one is a screen space, which is for HUD-like elements. People who are familiar with game dev would have worked with like putting HUD elements on their games. And the screen space provides you the ability to put HUD elements on your Blip as well. We provide a scene graph, which means that you can have a hierarchy of nodes parented and transformation stacks being computed in real time. You can also attach animation nodes to any of your nodes that are in your scene, and you can change the properties of the nodes that you want to animate over time. And in this case, I've shown a small example of where you can actually take a logo, which is a scene object, and then you can change its alpha from whatever its current value is to a value of 0, which is it's more like a fade out effect. And you can have it last a total of 1 second. The fading can go on for 1 second, 1000 milliseconds in this case. And at the end of the fade out, you can turn it back on to be fully visible. So that's what this animation, is this one line of animation code does. You can animate any of the properties of a scene object, from like its translation, rotation, scale, its opacity. You cannot change shader properties at this time. So I talked about the JSON file, which represents a static scene, and there is a JS file which provides the animation and anything that you want to do, any of the dynamics you want to do. Here's an example of a Blip. This is a robotic arm that shows, first of all, the organization of the robotic arm. In this case, the four parts of the robotic arm. They are all statically described in that JSON file as like in a parent-child relationship. But the behavior for how the cylinder is getting parented is changing at runtime. When you press the red color button, you can have it change the parenting of the of the cylinder from the conveyor belt onto the robotic arm, and then back again on the conveyor belt. So this can be programmed, and you have event handling on the red button. You have event handling and the end of event handling here on reparenting. This example shows like screen space elements as well as adding some behavior. So here's a nice a simple example of a cannon that is going to shoot out a cannonball, and you can control the orientation and rotation of the cannonball. Of the cannon, and you can get the ball to fire, and it's going to use the dynamics built into the. It's a simple like 20 lines of physics code that was written up for this particular example. And attaching elements to the screen is as simple as just attaching it to the screen node, and your elements are going to start showing up in the screen space. You can also do procedural geometry. Here's like a quick prototype of a Minecraft-like application if you want to build one. So in this case, all of the geometry that you see in the scene are procedurally created. There is no 3D model file at all here, right? We have some basic primitives for procedural geometries, like planes and spheres and cubes and stuff. But in this case, the cube itself is constructed as a 6-plane. The code on the bottom side shows you what that is, and then the code on the top tells you what happens when you touch So you have ways in which you can get the object that you're touching in the scene, and you can get that feedback, and then you can build upon that. That's what is happening here. So once you have created your blips, what do you do? Like you see, there are two ways to create blips. One is you can start off like in an authoring environment and continue to work only within that authoring environment. What we envision is we also see developers who are used to traditional game dev pipelines, where you probably are working on a DCC tool like Maya or 3D Studio Max. You're creating your scene and constructing your scene graph and hierarchies there, and then you kind of do an export, and then you start to write the program of the behaviors. So we want to support that model as well. So if you do that, then you have you can export out into the individual 3D files, the JSON file that I just mentioned, and then you can script your behavior, and you can bundle them all up into like a zip file and push it out into the Blippar dashboard, the developer dashboard. And once you do that, you can then publish your blip. You don't need to get into any of the creation tools that we offer at this time. So this is a very powerful way for developers to kind of build out their blips without being forced to do it within our tool system itself. For those that want to integrate tightly with our tool system, we do have tools which are currently provided as a licensed model, and you can use those tools to create blips, organize blips. This is more for the novice user at that point. So for developers, we want to give you the power of what developers are used to in their real world. Once you create your blips and upload it, you can then start to manage the different versions. You can go back to a previous version of your blip. You can download that and modify that, and then publish it back again. And you can also test your blip locally. If your phone is wired up to the with your laptop where you're programming for the most part, you can even test your blip locally, or you can test it off of our cloud system, cloud CMS system, where you can put your blip on what we call as a test code. Like in this case, you can pick the test code 298223, or you can type your own test code if you want to. And once you have put a blip on a test code, you can then share it with all of your friends or your clients, and then they can test it out and see how good the blip works. And once it's ready, you can publish it live. And once you publish it live, it takes like maybe a second for it to become live. So it's not like you have to publish it and then you wait for a few hours or a day to actually start blipping. So once that you have blipped and you publish your blip live, we also provide data analytics platforms, data analytics in our platform that let you look at how your blip is trending in terms of interactions, in terms of the number of users, where those users are that are blipping your particular blip. And if you want to add additional data tracking within your blip, like how many people actually clicked on this particular button in this blip, right? You can add telemetry for that level of data collection within your blip also. So with that, I'll hand it back over to Ryan, who can walk us through the rest of the.
I think we're just about out of time.
Yeah.
But just some final things to leave you guys with is we're in the process of doing a closed beta right now for the API, and Sunita's here in the audience with an iPad. So if anybody's interested in signing up, we'd love to get your feedback on our progress thus far. You can also sign up at developer.blippar.com. We're targeting early July for a release, and we're going to release this beta at no cost. So we're really excited to get you guys hands-on with it and start getting your feedback. Thank you, Satheesh, and thanks for everybody for watching.